So I'm going to ask a series of rhetorical questions. Tittering at the back is allowed. So the theme of this is open source and energy. So the reason I am here is because my primary motivation, and that of everyone on OpenTRV, I think, here is cutting carbon, working to ameliorate climate change. So fundamentally, the energy angle is about energy efficiency and climate change. Why open source? Well, I've spent a lot of time working in, for example, 20 years working in banks. And, you know, the best bits of software we get is quite often not the stuff we write ourselves, but the open source stuff we bring in. You know, if you spend any time looking at code, you know that the stuff that is being written by the guys who don't talk to anyone is often awful, and the stuff which is done out in the open is often very good. Not necessarily because the people who contribute to open source are geniuses, but because of the many eyeballs thing being true. That if lots of people are looking at it, you get wonderful feedback from people, and you would never have thought of, oh my goodness, that's such an obvious improvement, or I'm an idiot, I won't do that again. So 30 years, I guess, of experience in software suggests that open source, if you can do it, generates better quality systems. And in any case, I want a public good to come out of this, and I think it's a better public good if I can actually give it away for other people to do it, who may be smarter than me at doing it anyway. So I claim that with the OpenTRV project, the combination of having a social goal, which is the climate change thing, and doing it with open source buys me a heck of a lot of love and free help. So for example, Mike here in the audience has brought me, this is a little thing we're doing, a Franken valve, so it's got our electronics and someone else's hardware in it. Well, I wouldn't have the time or the skill to do this. You know, here's Mike doing this for me. Well, not me, but for the project. If I had a big commercial organization, I'd have difficulty making something like this. So the open source love gives me access to a whole bunch of things that I wouldn't otherwise have access to. So anyway, going back a step. So I am a founder of the open source project, OpenTRV, and there is now an OpenTRV Limited, which has had some funding, EU funding, from a very good accelerator called Climate Kick. I don't know if any of you know about it. That's EU money. And we have got a project which will start funding us in April with Innovate UK for separate things. And we are motivated by, we're motivated by carbon. The OpenTRV idea is that you take your existing thermostatic radiator valve. Who's got radiators for heating? Right, who recognizes what one of these might be if it just had an ordinary dial on top? Right, so this is meant to be just the same. Imagine we've got a dial on top of this. It's meant to be exactly the same. You put it on, but magically it saves you an extra 30%. And the way, or 50% if you go and put something on the boiler as well. And it does that by as simple as occupancy sensing. So a big problem with heating in UK housing stock is, A, we have thermally crap housing stock, so we let a lot of heat out. But secondly, the official way to do it is still to have, basically, unless you're a big house, one thermostat shoved somewhere cold in your house, where in case you need heat anywhere else, it's already on. So that's running your boiler just in case you need heat. And then possibly old-fashioned flow controlling valves by hand, or possibly mechanical thermostatic radiator valves. But of course, they have no idea whether you're in the room or not, and 60% of people, according to a DECC survey, are quite happy to admit that they leave heating on in rooms they're not in. And I can tell you that we have exceeded 50% savings. You know, it's not that hard to do. So all this thing does is buried somewhere in here. Mike, did you leave a space for the opto to work in this thing, by the way? We might need that. Right, in here is a 12-pence light sensor, which can infer a certain amount about whether you're in the room or not by simply observing light levels. And with that, for example, it's able to say, oh, you're not usually in the room at this time, the light's out, I'm gonna drop the temperature target by 3 degrees. Well, that's a 30% saving straight off. And having something at the boiler, listening in and only turning the boiler on if at least one of these is asking for heat, can give you another 20% saving. So that's why we're interested in why OpenTRV exists, because that's huge, huge carbon savings, maybe 8% of the EU's entire carbon footprint by replacing the 500 million radiator valves across Europe. And our target price is £10 per radiator valve. So 100 quid a house less than. Now, that's roughly the same effect as external wall insulation. And I can actually say, I'm not a cab driver, but I had that Secretary of State Davy in my back garden, and when he was proposing to scrap putting the loft insulation in for solid wall insulation, I said, it's a fine idea, but at sort of 10,000 quid a house, it's rather expensive, isn't it? Well, I reckon we can give the same effect for 100 quid. So that's why I'm doing OpenTRV. But it's not the only thing I'm interested in, that we're interested in. So smart grid applications, which you've mentioned, distributed stuff. There's a whole pile of stuff I want to get on involved in that. Don't have any time to do it. And also, when we've done this, now what we've built here, if we get this down to a tenner, and it's got radio in it as well, so it's a bit more obvious in this engineering version of it. It's got radio, it's got sensors, it's got a microcontroller, it's got an actuator in here. It's got some user interface. We've just built a low-cost IoT, Internet of Things platform. So we had instead of realizing you got it all wrong and have to change your mind, these days it's called pivoting. So we did a pivot. Oh, I'm sorry, I'm not meant to be that cynical. So what we've decided is that our OpenTRV thing is the first vertical application of our IoT technology platform. Now, did I get enough buzzwords in? Thank you very much. But it was worth £150,000 of UK government funding starting in April. So apparently this, and I can give you the spiel involving these 5 Duplo bricks as well, but basically that was worth 150 grand from them. But what we're interested in is IoT as well. And again, doing it open. And again, what we're trying to avoid is other people having to reinvent things every time. So a company we're working with does building monitoring and a stack of sensors for them to measure something like temperature and light levels and so on. By the time the engineer has installed it, because it's proprietary and it needs tweaking and all this sort of stuff, is over 100 quid. Now, we're aiming at that £10 price point. We have to work very hard at it. I mean, Ken was looking slightly tense when I was telling him what our factory gate price was. But that's actually the primary thing we're not doing. We're not really doing stuff clever with technology. We're trying to commoditize the hardware. And again, I think open source is the way to do that, because I certainly don't have the engineering smarts. And I don't think anyone else in the team individually has enough, or in the open source community, to get us a factor of 30 reduction. This is about 60 quid to put together, very roughly. Down to the 2 quid it needs to be at factory gates at the retail price is a tenner. Now, actually buried inside this Franken valve is a third party's valve which retails for 8 quid. And it's essentially the same content as ours, substituting a radio for an LCD display. So I think it's eminently doable, but I don't have those skills. And so the way to bring those skills in is to make it available to everyone else. And indeed, what we're trying to do is provide a reference implementation all the way from your valve pin through to your boiler that anyone can use to build compatible stuff. And our IoT stuff is the same, and we want to do the same with our dynamic demand, frequency response type stuff as well. And, by the way, share the hardware and so on. And, by the way, all our stuff, this thing thinks it's an Arduino Uno. It's very slightly wrong, but I actually program it with an IDE and the normal FTDI thing. So this stuff's incredibly accessible for people to fiddle with as well if they want to. So we're interested in all of those things, the space heating, the IoT and the smart grid, because we see them all a way of saving carbon, cutting carbon, getting more people into the game because we're making huge reductions in the cost and the difficulty. Most people in IoT are software people, not hardware people. So the spiel to Innovate UK is take your power source you choose. It could be, let us say, a hydrogen cell, or it could be batteries, or it could be energy harvesting. Plug on your standard microcontroller unit, which is one of our standard boards from this. Choose your radio backhaul, which might be GSM, or it might be ISM, or it could be Wi-Fi potentially, probably a bit power hungry. And choose the sensors you want for this unit, and as you plug it together, the data starts appearing in Xively or somewhere. And bang, it's totally now within the realm of a software developer. They don't need to have a soldering iron or read data sheets or anything. So our approach is to make one of those circa 10 quid, at which point the old adage about if you can measure it, you can manage it. And then I think we get huge carbon reduction. So that's why we're interested. That's why we think the open model is good, because we want to maximize adoption and also commoditize the hardware so everyone can join in. So this is all very nice, and it's perfectly honorable living off government money and doing research. You know, there are lots of university researchers who will never go out and earn a commercial pound in their lives, and we don't think they're failures for doing so. I think, you know, Einstein is allowed to have lived off state money. I don't think he was scrounging anyway. But, you know, Mrs. Thatcher's jibe about running out of other people's money to spend is true. And so we need to find a way of being self-financing, because I think we can do a better job if we can choose how we spend our money. And that means we have to somehow marry this. I was written off by an MIT business professor the other day as a granola-eaten tree hugger. So we've got to somehow combine the granola eating with running a real business. And we're still working on that business model, by the way. And one of the things that brings up is, how do we operate with the non-open source elements in the world? So one thing we've done is we're using Apache rather than GPL, for example. So that means that stuff that we generate can be used by commercial entities without giving stuff back. Most of you, if you've got a Linux thing, by the way, you've got some of my code sitting in there, but it's probably sitting on your Mac, and it's probably sitting on any commercial Unix you've got as well in the NTP daemon. So it was important that that wasn't necessarily tied up with a license which is unfriendly. So in fact, I get some of my own code back in my Apple, bizarrely, 20 years later. So that's one thing we've done. But it's still part of the business model we're working on. We had a chap who would like to invest as an angel investor saying, but how are you going to make bazillions? And actually, we don't need bazillions, because we were in banking. So if we want bazillions, we can just go back to banking and I just go and do a contract again. So we don't need bazillions, but we need enough to be able to have a sustainable business. Okay, and it's a hard. Part of the reason we got funding out of this EU entity is they think we're probably mad, and they want to see if we can do it. Now there are people like Red Hat who have a model where they're selling the sizzle, not the sausage, and that's absolutely fine, and that's maybe how we do it. But it's not clear. So ask me in 4 years' time whether we made the bazillion or not. So one way of doing it, the hardware in here, by the way, is 80 mega. So it's the same thing from an Uno, the 328. So one issue here is, if we were, our project, the IoT Launchpad project we're doing, involves putting sensors in bus shelters. Now, ultimately, you'd like to do something so that they can be popped in once and no one ever has to revisit them again, ever. Okay, so probably not even a hydrogen cell. It's probably got to be energy harvesting or something. In the interim, we don't quite need to achieve that, but we've got to choose our backhaul. And at the moment, we talk ISM band 868. Now, who's heard of Sigfox? Okay. So Sigfox is an interesting idea. They're basically selling ultra narrow band communications, where you buy a number of 8-byte frames you can send in a day. So I can have 1 or 2 or 20, I don't know what the upper limit is. And our current hardware would almost certainly talk to that. So we can have the stuff which I currently use to talk across a house. Actually, you can have an antenna halfway across London, we'll pick it up. All right? But they almost certainly don't want to let us put their super secret source inside an open source thing that other people can get at. Now, it's a bit like the binary blobs in Linux. So I think we have to accommodate binary blobs, because otherwise we have to run a second microcontroller with their code on it. Now, it's getting a bit silly when I'm running a thing on 20 microwatts, it's running 3 microcontrollers in the box. And we're talking to a bunch of people who are going to the Nuremberg thing next week about doing voice detection, not listening to what you're saying, but just that you're there for my occupancy sensing. And that's another ARM processor. In fact, it's far more powerful than my main microcontroller at the moment. So in order to bring them together, I almost certainly need at least to go to a microcontroller where I can set a fuse bit saying, and no one can read the code out again. So there are going to be things like that where other people will feel confident to put their non-open resources into a package that we provide and feel they aren't going to get stolen. So there are probably going to be some technical solutions as well as the legal ones such as SolderPad and Apache at that level. So my next point is, what can't we be open about? I mean, I'd like to do absolutely everything in the open. Now, we know, of course, that although as children we're told it's always best to tell the truth, possibly mentioning the fifth pint to your other half is not a good idea sometimes, and possibly, or the sixth, or the 10th, and possibly it's best not to have all your detailed business dealings out in public. So there are some things the emails to people we send probably can't go out in public because there's some sensitive stuff in there, people's personal details and so on. But more particularly, we probably have to support some code, some hardware and software, which is unlike, all our software is Apache, our electronics is SolderPad, even the 3D box design for our engineering samples is published. That's fine. But when we combine it with someone else's, we can't inadvertently give away other people's secrets. Plus, if we're going to carve out one application for this stuff, is not just in the home, where we think we'll make the bulk of the carbon savings, but to make us some money, the obvious deal is you go to a hotel, say it costs you 100 quid for a small hotel, not big chains. They don't have facilities manager. We say it costs you 100 quid a year to space heating per room. We can halve that for you, and we'll rent you one of our devices for 25 quid a year to do it. So that's great, but we've published our hardware design, we've published our software, and some enterprising chap in Shenzhen produces something which undercuts our hardware and does a knockoff of our software, and suddenly we've lost the ability to get any revenue at all to go on financing ourselves. Now, we don't want to, like that angel who wants us to make Brazilians, oh, give up your social goal, they're useless. No, I think not. I think that's our motivator, so we're not going to give that up. So we need to keep this open. We need to keep at least a reference edition there. How do we make a business alongside that? And we think it's a bit like some animals are more equal than others. So we'll have a published reference design. We'll probably have a design based on, for example, the chip you were telling me about, assuming it's smart enough to do some of these can't read the code out again stuff. And we'll do nice things. So if you're a hotel and you want to integrate all your stuff, we'll have some nice key pre-sharing or pairing or management facilities in, which will hide in another corner of that ROM, so that ours is completely compatible with all of the other stuff in our ecosystem, and we'll have our own stamp on it to say compatible protocols, compatible with all this sort of stuff. But ours will be nicer to use than buying it from the enterprising chap in Shenzhen. And we think that's how we have to work to give it away, to get the primary carbon savings, which is domestic, but which we don't think we will ever make any money from, and yet carve ourselves a niche in the commercial entity where the bean counter or the hotel owner can say, ooh, halving my space energy bills. That sounds like a good idea. So can we still make the bazillions? We don't know. Ask me in 2 years or 3 or 6. And a final point I was going to bring up here was, again, that would-be investor said he regards government funding as a cancer. Now, that's why I brought up the defence right up front, saying, well, of course, it's perfectly honourable to be a publicly financed researcher, and we could do that, and if we somehow don't make a go of making the bazillions, it would be perfectly reasonable for us to go on getting, say, Innovate UK type funding to make reference editions for other people to use, providing they're useful and we're not just building better mousetraps which no one ever looks at again. But I don't think it is, because we're trying to get a public good out of this. So our cheap IoT platform that we're trying to produce, one of the reasons we can just give it away is because we're being given government money to develop it. We don't need to hold the whole thing so close to our chest to recoup our money from it. We need to hold a little bit of it to our chest, but not all of it. And so I think an important aspect of, say, Climate Kick, which is the EU funding, and Innovate UK, is allowing us to give the public element of it away more quickly. Because it's like tying up all this effort in wood chip stuff, and then, company dying. Oh, well, you might as well not have bothered. You've just burnt a few $1 million of someone's money, and there's nothing to show for it. If we go down, everything we've done will still be there. It's a bit like Netscape. carefully, before Netscape actually died, they basically put all their code into as near the public domain as they could. Company dies. Oh, and you've got something, you know, called Mozilla or something that starts up the next day, by amazing coincidence with a lot of the code in there. So I would hope that by putting stuff into the public frame earlier, even if we can't make full use of it, other people can. And I think that's an advantage of open source because, you know, there's 7 billion people on this planet, most of whom are smarter than me. And I'd like to give them a chance to develop what we have developed to date. Now, the only thing that was on my laptop that I was going to show you was where we've got to on our valve. We've spent a couple of years working on this since I created the open source group. And we've finally gone through a round of production engineering about the wrong side of this bloody winter. Just watch the tears come out of my eyes. So it's going to emerge in February rather than October when it should have done. And this is a little stopgap which Mike and the Thames Valley RetRap group and so on have been very carefully kindly helping us do, which gives us a very quick instant solution, which is a third-party mechanics, our circuit board in there, and with those theoretical 30% savings simply by unscrewing your old valve head and screwing your new one on. No gas person, no Part P electrician, no plumber is the idea. So the important point is if we get this wrong, the bits we've got right so far, and we do have a complete reference system now published, although it's not actually fully operational at the moment, is that the next person, even if it isn't me, can still make that work. So I think the real value of open source here is preserving the effort that someone else has put in and making it available for others to build on, like patents, but without the 17-year delay. Okay.